Hello everyone, this is Amir Muhammad. Warm welcome to you. Welcome to AR Engineering channel. Today we are going to learn how can we use XFLR5 for creating a dihedral wing, and also how to define and analyze, how to create airfoils, how to analyze the airfoil, and all the features of this software with a simple exercise. So currently I'm using XFLR5 v6, so you can also download the last version, and it doesn't need very much memory. So first of all, we have to choose an airfoil, then actually analyze the airfoil. So I'm going to modules and actually choose direct foil design. Actually in this environment, I have to choose a specific airfoil that I need to use in my plane. So go to foils, NACA foils. So actually the NACA foils are actually already exist in the library of this actually software. For example, I will choose 2412 NACA airfoil and say OK. Here I'm going to actually increase the width to see the airfoil much more better. Now, after you choose your airfoil, it's time to analyze this airfoil. But how can we do this? Go to modules, Xfoil, direct analyze. And whenever you choose that option, you will guide to this environment, which is related to airfoil analyze, and also these graphs. Actually, they are aerodynamic coefficients like at CL, or coefficient of lift, to coefficient of drag, or coefficient of lift to coefficient of alpha. Not coefficient, actually it's alpha. Sorry for that. So and also you can change these graphs. It seems what is your need, what actually graphs you want to export. So in analyze, I will choose batch analyze. It is because I can actually define more Reynolds numbers, and actually I can cover more here, actually cover more Reynolds number here, and the alpha is already from -3 to 10 degrees, so that's okay for me, and I will choose analyze. So it's starting to analyze, and after actually the analyze completed, I will close this window, and as you can see, the graphs already draw for me, and I can actually choose this data for optimize my actually design, and also whenever I'm going to make a real type, a prototype, it's very helpful for me. So after all, I'm going to again module and then wing and plane design. So in this environment, I have to design my own airplane. So in plane, I will define a new plane, and actually I uncheck the elevator and fin because only I'm going to draw a dihedral wing. So first I have to choose a name for my plane, so I will choose AR. So AR is okay. Actually this seems like our channel name. So in define option, I will come here to define my wing. So first of all, I need to have simple chord for my airfoil. So I choose a simple chord for both one, and we are going to analyze the half of wing. For example, here as you can see, it's 1 meter, but wing span is 2 meters. It's because we are actually analyzing the half of wing. We are going to design a half of wing, and it will generate it as a symmetric, as you can see here, to other side. So also we didn't need any offsets, so it's 0. Now first I'm going to choose my airfoils here, the airfoils that I was actually generated in previous section. Now if I choose here 5 degree, it will give me a root head roll wing. Now as you can see, I have a root head roll wing, but I'm going to have a multi-section dihedral wing. So for this I'm going to insert after section. So if I choose this one and here choose 5 degrees and here choose 10 degrees, as you can see I have a multi-section dihedral wing, and that's insane, that's perfect. So also you can change the panels for X and Y direction and coordinates, but now I don't actually change them because it's need more time to calculate. So I will save this and again save this one. Now as you can see, my main wing is come here, and I can see if you actually check the surface option here, you can see the wing much more better. So in analyze, I have to define and analyze. I will choose fixed lift, and actually I will choose VLM2 and uncheck the viscose because many of my actually steps will uncovered. So in interior I will choose, for example, 1 kilogram for my all the wing. In reference dimension, aero data and extra drags, it keeps same, we don't need to change anything here. So as you save here, now you can click and analyze, and as you can see the analyze were completed, and I can easily see all the parameters I need, for example streamlines, lift, or actually the pressure throughout my wing, induced drags, and anything you need. So I hope you actually enjoy this simple exercise and tutorial in XFLR5, and please subscribe to my channel because I'm going to record many other exercises in many different actually engineering softwares like SolidWorks, AutoCAD, XFLR5, or CATIA. So I will be happy to actually subscribe to my channel, and thank you all. Bye for now.